It's 11:30. I think we can get started. I just want to thank you all for joining us for this concurrent session on the theme of managing data and research products effectively. We'll have 3 presentations today, each for a total of 15 minutes. That includes about 12 minutes of talk time, followed by about 3 minutes for Q&A session. After all the 3 talks are complete, there'll be more time for questions, and then we can also have some general discussion for the final 15 minutes of this hour. Audience, you're welcome to post your questions in the Zoom chat. I will look for those questions and then share them with the presenters. And presenters, when you've reached about 11 minutes in your talk, I will interrupt your talk and alert you for the time. So the first presentation today is titled HubZero, HubDrive Prototype for Projects and Publications. It is a pre-recorded presentation, but the presenter James Graves is here for any live Q&A to follow after the presentation. Abe, you want to start the presentation?
Hello, I'm James Brian Graves, a computer scientist, researcher, educator, and community organizer. I've been working as a contractor for HubZero off and on since 2015. HubZero is based in San Diego at the San Diego Supercomputer Center, SDSC, at UCSD, University of California at San Diego, but I'm currently based in Amsterdam and welcome to my office in the Netherlands. What is HubZero? I'm glad you asked. The HubZero platform is an open source cyber infrastructure where research teams can host analytical tools, publish data, share resources, collaborate, and build communities. The HubZero platform originated from the NanoHub project in 2002, and 18 years later, the platform now collaborates directly with over 35 hubs or science gateways using HubZero's framework, all hosting research projects. These projects can range from hard sciences, such as civil engineering, differential equation modeling, geospatial modeling, and even soft sciences, such as intercultural learning and K-12 education. Today I would like to tell you about HubDrive, a prototype collaboration tool for teams which facilitates the content management in the HubZero CMS, for example, around projects and publications. In 2018, Michael Zentner of HubZero and Gerhard Klimek of NanoHub mentioned the interest in a desktop tool which fits more into the researcher's workflow, not unlike Google Drive or Dropbox. I had already been working with the Hypercore protocol, formerly the DAT protocol, and immediately saw the potential for implementing such a feature with this new peer-to-peer based technology. What is peer-to-peer? Well, I'm glad you asked. The traditional internet is built on a client-server architecture. This puts the server in a central role that serves data basically to end users. So if I have 2 people who want to collaborate, let's say Brian sitting over here and James sitting over here, and James wants to share a file with Brian, he first has to upload that file to the main server as a client, and then Brian's client needs to make a request to that server to get the file back. This has worked great, it's scaled. This is how HubZero's infrastructure has worked for years and probably will continue to do so in the short term, but it has one minor flaw, which is if the server ever disappears, there's no redundancy to the content requested by Brian and shared by James. On the other side, there's peer-to-peer technology. In this case, you can have James here and Brian here, and Brian can make a request to James for a certain piece of content, and James can send that to Brian directly. Similarly, you can have a server acting also as a peer, interested in content shared by James, and also interested in content shared by Brian, but not so relevant in this particular use case. And if that server disappears, then this sharing can still happen. That data is still available. There's a redundancy there. Similarly, the ability of HubZero to sit as a peer in that system allows it to pin content shared by James, and this is at the core of how HubDrive works. Content is pinned on that server, and while it's pinned on that server, it becomes available to the traditional CMS system and allows it to be easily integrated into our projects and publications components. Again, long since part of the HubZero offering. DAT is a protocol for sharing data between computers. DAT's strengths are that the data is hosted and distributed on many computers on the network, and that it can work offline or with poor connectivity, and that the original uploader can add or modify data while keeping full history, all the while handling even large amounts of data. Is it secure? I'm glad you asked. DAT transfers files over an encrypted connection using state-of-the-art cryptography. Only users with your unique read key can access your files, allowing them to download, view, or reshare the files. To update the contents of DAT, users must have the right key. By verifying hashes during transfer, DAT makes sure that no data is altered or corrupted. As long as you don't share the read key outside of your organization, then the content will remain private. Here's a quick demonstration of DAT. We're going to make a directory called Our Amazing Research, and we're going to put some data there, some trivial data. Just going to echo Alice into Bob. Now we can just type DAT share, and then DAT's going to generate for us a special cryptographic URL, which James can then share with Brian. Hi, I'm Brian. Brian can then get that URL, quickly open up his terminal, and then type dat clone and paste the URL, not unlike Git. And just like that, with an open dot, getting a Finder window, you can see that the folder was easily transferred containing the data from James. Yep, got that data. Looks amazing. Now let's see how HubDrive works. I'm doing some amazing research on homomorphic encryption with my collaborator, Brian. We would like to bundle that research into a HubZero collaborative project and ultimately publish the results. Brian is a bit better at writing than myself, so I'll just drop the results in my HubDrive folder so that he can get to work on that publication. The first thing I have to do is generate some data for the publication. HubDrive fits seamlessly into my workflow, and I can just simply use my terminal, create some output, put it in a folder, and now by just dragging that folder into HubDrive, I can create a HubZero based project with files that I can share with Brian. Looks like I got a message from James. Indeed. Yo, Brian, I added some output from the quantum encryption research. I guess I should start that publication. Yeah, indeed. I do see in my HubDrive the QE output project. It's also synced with my Finder. The output's sitting there. Fantastic. Gonna just open up HubZero here, go to projects. Ideally it's gonna be there. Yeah, indeed, I see the quantum output project. Let's start that publication. Click publications, start publication. Boom, done. Scrolling down, let's add that output. Here, yeah, there it is, output 1. Whoa. Let's rewind a little bit and have a look at what just happened there. Not only was James able to create a scenario where Brian had those output files synced to his local file system, but they were also available as a project with files attached in the HubZero CMS system. Pretty amazing. We probably need a little bit more output than just that. I'm going to ask James for a little bit more output here. think we need more output. More output? Ah, well, he's not wrong. So let me jump over here. Again, my normal workflow. So I'll just run my script, output that into output to text, and then I can let Brian know that there is some new data there. Just added some. Okay. James added more data. Great. Let's have a look in the project. Already synced. Yep, it is, but something's off here. Ugh. What? The data's no good. Alright, I guess I'll just generate some new output here. Ah. Okay, yeah, remove the last data. Let's kill that. RM, yeah, yep, output 2, done. Should be deleted. Boom. Is it gone? Yeah, looks gone to me. Hey, yep, great, thanks. Yeah, make more data, of course. Alright, so let me run my script one more time. Yeah, okay. Should be all synced up now. Done. Great. Alright, let's see. Is it there? Indeed it is. Let's select 1, 3. Looks great. I think our publication's ready to go. Let's ship it, man. Thanks.
So I guess that was the end of the presentation. James is here for any questions.
Sorry, I have a question.
Yes, go ahead.
Okay. Hi, James. This is Lee.
Hey, Lee.
This is probably a silly question, but I just be clear. Does that mean that like you had James created the data? I think you said, and Brian was reading the data. Did I get that right? The person reading the data there could not delete it. It's only a read only, or is there a possibility that that person could also edit the data?
Yeah, so I think in this case, there's a lot that can be done from a user experience standpoint, but the intention of showing it in this way was all the changes that James was making as the data creator were then instantly being translated to both Brian's local file system and the file system that was sitting on the gateway. So yeah, it was a bit of a contrived use case that James deleted it, but I did want to show that that Brian was getting those syncs.
Okay, thank you. Yeah, I liked it.
Oh, thank you.
Could I ask a question?
Sorry, go ahead.
Hi, James. This is Carol Song. I'm wondering, so you showed the command line. So for people who don't know how to use command line, how would they use that? Do they just create folders in the Finder, or how does that work?
Yeah, the command line is not necessary at all in this case. What I was trying to show with the utilization of the command line and also the Finder, so the folder window, was that the intention here is just by modifying the file system. So whether it's with a traditional sort of file explorer or the command line, or maybe even saved as long as that file is changing in that folder, then it's syncing to the CMS system and to the collaborators' local file systems. So it's not necessary. I probably just chose that tool as an example because I'm more of the nerdy programmer type, but it could have been literally any tool.
So it sounds like it seems similar to things like Dropbox, Google Drive, the client application. So then do people need to download and install a HubDrive app or something like that?
Yeah, the idea would be that this would be a piece of standalone software that sits on your computer. I think the differentiation between this technology and something like Dropbox and Google is, well, it's just the information stays in your organization as opposed to going to a third party and being hosted there. And then also, if for whatever reason your hub or your gateway falls over, you can actually still request that data directly from other peers in the system. So it can go from researcher to researcher without ever making a stop on a central server.
Thank you. Looking forward to trying that out.
Yeah, cool. Thanks for the question. And nice to see you.
Any additional questions for James?
Hi, sorry. My name is Lan Jiao. I have a question. Is there a size limit on the amount of data that can be used this way? Like if I have a very large modeling output, would it cause a problem to sync with the other side?
Yeah, I think that's a super interesting question. We've always had size limits on the CMS system, kind of based on kind of usage tiers, but there's nothing from a protocol standpoint that would prevent you from transferring large data from researcher to researcher. So it may be that there may be limitations on the CMS side, but again, the protocol will let you send terabytes if you want.
So you mentioned a little bit earlier, like this technology also allows peer-to-peer type of transfer without going through the hub CMS. Yes. So is this automatically configured to do that, to do it that way? You don't need to, the user don't need to do anything, right? It's already set that way.
Exactly, yeah. No special configuration. You don't have to be a hacker or something to figure it out. It just works.
Okay, thank you.
Okay, thank you. So we can continue with the questions right after the three presentations. So we can move to the next one. The next presentation is titled An Open Source Managed File Transfer Framework for Science Gateways, and it is presented by Dimuthu Vanipurage.
Can you hear me now?
Yes.
Yes. Yeah. Hello. So I'm Dimuthu Vanipurage, and I'm a research engineer at Cyber Infrastructure Integration Research Center at Indiana University. And I'm going to talk about a product called IRAWTA MFT, which is an open source managed file transfer framework for science gateways. So before going into the product details, I would like to go through some of the challenges we have seen in specifically in the file transfer scenarios in gateways. So the first one is the cross storage transfers. So basically you might have different type of storage types, and then how do we do the protocol matching and the protocol translation between different storage types if you are data transferring to a gateway. And the other one is the performance, as always, but the performance might go in two ways. For example, let's say if you have a private dedicated link across two endpoints, then you can utilize the maximum bandwidth. But in some cases, you are transferring data to a public link. In that case, you have to be much fair and give the opportunity to the other transfers as well. And the other one is the data path optimization. So this comes into the picture in the cases where you have endpoints having multiple network links, and the transfer solution should be smart enough to pick the right network link to get the maximum throughput, or in some cases, even you have to reduce the network cost, especially in the cloud endpoints. The security is also very important into the cases where you have sensitive data sets to transfer. So in that case, you have to go to more constrained and secure paths. But in some cases, you have public data sets, which doesn't need that much of security. But in that cases, you can focus more on the performance of the data transfer. And in either case, you have to be very careful about the integrity, and the integrity should be preserved at the end of the transfer. And this is like a very recent use cases, and like very like famous these days. People are bringing their own storages into the gateways, especially with the advancement of the cloud endpoints and cloud resources. So in that case, the gateway should be able to plug new storage endpoints easily, and it should be accessible for the end users to the gateway APIs or the UIs. So these are some of the data science solutions that we have observed. We categorize them based on the open source, community adoption or the deployment mode. So we have like discussed about this in detail in the paper. So then I would like to go back to like what's IRAT MFT. So IRAT MFT is not itself a product. Why we call it like a framework for people to deploy their own managed transfer platforms. So it's designed in a way like it's fully pluggable. You can configure your own credential backend and the resource backend to the MFT framework. So then you don't have to manually copy or clone the credentials of your existing gateway into the MFT framework. So the MFT framework can automatically call to your existing backend and fetch the data. And it has easily extendable protocol interfaces. For example, you can write your own protocol implementation for the data transfer, or you can even improve the existing protocol implementation like SFTP, and you can easily plug the new version. And so the IRAT MFT doesn't come with a fixed deployment pattern. So it could be vary based on the quality of service you want, and even the security, and even the maintenance complexity you want. So I will cover this topic in more detail in the later slides. And the other aspect is that sometimes it will be a concerning matter when the data flows through your gateway backends. So if you use like the MFT platform like this, like there are ways you can isolate the data paths and the control paths from the gateway backends. So in addition to that, it has active metadata capturing of the transfer, the files that have been transferred, and it's doing the replica management as well. And more importantly, so the IRAT MFT is an open source framework, and it's Apache 2 license, and it's currently managed under the Apache Software Foundation. So anyone can contribute and watch the code and see what's going on. So this is a very top level architecture of the IRAT MFT. It has at the top layer, it has external APIs for the users to submit transfer requests. And it has the framework extensions. As I mentioned earlier, you can plug your own credential backends and the resource backends of your existing gateway backends. Then it has the metadata collection, data transfer, and data browsing components in middle. And underneath, it has the MFT agents, we call it, which are the actual agent which are doing the communication across the different type of storage endpoints. So on the outside, we have different kind of cloud endpoints, even HPC, or even you might have a databases. So the MFT agents are smart enough to talk to these endpoints according to the protocol they support. So I would like to go to a simple scenario of how the files have been transferred using the MFT framework. So the use case is you have data store 1, it's having some file, and you need to transfer the file to the data store 2. And then you install MFT agent. We call this pattern as the end-to-end transfer. First, so this is the MFT framework that I mentioned. First, the user sends a request to the API service. So the API service gets a request and put it to the console, the event-driven message bus, and the message is forwarded to the MFT controller, which is the coordinator of all the services. So then it reads the message and validates whether this is right request coming from the right user, and then it sends to the right MFT agent. So the agent then deserializes the message and talk to the resource service to get the resource metadata of this particular file, and talk to the secret service to get the credentials to talk to the data store to. So once it has received all the information, then it starts to get the data from the local file system and push it to the data store to using the credentials it got from the secret service. So this is like a very simple diagram which shows the previous use case. We call it end-to-end transfer. So to do the end-to-end transfer, you should have agent installed on either side, or you can have agent installed on both sides. It's your preference. And so the MFT platform is sitting outside and sending the control signals, and the data path is only between the two endpoints. So this is recommended in the cases where you have sensitive data transfer requirements. So even like if you need some high throughput data transfers, you can use that because there's no any third party entity involved in the transfer. So the second use case is we call it zero intervention, because in some cases, it's not practical to install agents or some binaries on the storage endpoints because due to the security or the policies enforced by the endpoint. So in that case, you can use an external agent to pull the data with according to supported protocol of the source resource and push it back to the destination endpoint according to their supported protocol. So here also you can put the agent inside the network boundaries, and you can control those agents from the MFT platform from the outside. Here also the data path and the control paths are separated. And this could be useful in the cases where, as I mentioned earlier, in the cases where you don't have any authority, and you might the data transfer is not like the sensitivity of the data is not that much critical. So, and this is another extension of the zero intervention transfers. You might be able to define DMZ boundaries inside the MFT platform. So the MFT platform is smart enough to keep the data inside these DMZ boundaries and select the right agent to the to transfer data in between the storage endpoints. And this is another use case. So you might have the access to multiple cloud endpoints by different vendors. And if you need to transfer files in between different vendors, you can use public cloud agents to do the transfer and use the MFT platform to signal the agents to do the transfer operations. So this is a little bit advanced use case. So for example, your laptop contain some research data, and you need to expose them into the public endpoints. And in that case, you can use the MFT platform to expose them using even through the network firewall provided by your service provider. So so that's all about the use cases. And so now I'm going to briefly go through, like, let's say you have a gateway, and how do you integrate the IDOT MFT platform. So first thing, as I mentioned, like earlier slide, you need to have plugins for your credentials and resource backends. Once you have configured that one, then obviously you have to change some code fragments of your gateway. Instead of doing the transfer manually, you can talk to the MFT APIs, and it provides all the transfer and monitoring endpoints. So if you are more interested, you can do some advanced integrations, like you can look at all the storage endpoints as a one single global file browsing view, or even you can do the searching and indexing through different endpoints, and you can do the data grouping or repository management if you want. So all are provided through the MFT API. So these are like, so because our framework is very extendable, so we are looking through new innovations and see what are the advancement of the technologies in the area where the file transfer happens. So the first one is we are currently looking at how quick protocol, which is a UDP-based file transfer protocol developed by Google, can be used for our agent-to-agent transfer scenarios. and then we are looking at RDMA-based data transfers, specifically in the clusters where they contain the RDMA supported network cards. And in addition to that, we are actively looking at how we can improve the data encryption. And usually data encryption doing on the CPU could be like a very expensive operation, and there are some technologies where you can do the encryption at the chip level, and we are looking at those opportunities and see whether we can improve our overall transfer performance. And so that's all about the idea of MFT for now. And please go ahead and check out our code from our GitHub page, and it's deployed under the Apache umbrella. And you can go and look at the issues, and maybe like you can give your feedback as well. And because the project is still at the very early stages, and we are actively working on some feature improvements, and you can also contribute. So these are some interesting ideas that we are like planning to work in the future, but we haven't planned yet. A plan about the development iterations. So you can maybe like contact us and give your feedback as well. For example, we are doing some research on smart network path detection across agents, and we are doing some work on transfer time detection before initiating the transfer based on the historical data and machine learning models. And then we are planning to see some automatic fallback operations across agents, which is a distributed system problem. And these are all open problems, and we are always open to get the feedback from you all. Thank you.
Thank you, Dimit. Do you have any questions for him? If not, maybe I can ask one. So at least in the, when they're in the HPC resources, when people are trying to transfer files, usually they have like, gazillion, like 10,000 files that they want to transfer.
Mm-hmm.
When they're doing that, is there any like data management practice, like in the sense you want to like maybe compress them, put them as a zip file to transfer, just to improve the network latency? Is something that you thought about?
Yes, it's on our pipeline. But right now we don't support that one. We are transferring file as it is. But it's yes, of course, it's a very valid use case. The only thing is that it can be done only on the file system, on the like HPC file system. We can't do that probably on the cloud endpoints. So we might be considering that in future, but not right now. We don't do that one.
Okay, thank you. So we can move on to the next talk. That's the third presentation. The final presentation is titled "Fair Data and Secret Gateway: A Research Data Alliance Adoption Project," and the presenter is Rob Quick.
Hello, and let me share my screen here. Share and view. Let's see, and let me know if you're seeing my screen correctly.
Yeah, we can see it.
Okay, great. So somewhat inspired by the plenary talk this morning, I'm going to start off with a statement here that I hope can lure everybody in. I think it's a statement that actually everybody will agree to, but it's easy to get lost in a conference like this where we're talking about gateways. But the statement I want to make is that the research enabled by a gateway is much more important than the gateway itself. Right, so we all have got jobs that relate to gateways, so it's hard to think about that. But I think it's important to realize that the research, the gateway is a tool to accomplish the research, and the research is really the goal here, and research that allows some decision making or some advancement in wisdom. So I wanted to start with that statement because I think the gateways themselves are somewhat transient. They come, they go. The research, though, should be permanent. And one way to think about that is by saying that we want the data, and in fact even the workflows, to move towards the FAIR principles. And at this point, everybody's probably heard FAIR so many times that they're tired of it, and they know what the acronym means. They know findable, accessible, interoperable, reusable, like the back of their hand. Though they may not have put much thought into what those words mean beyond that, and we'll talk a little bit about that. And in fact, the project that we got funded by the Research Data Alliance to do was to look at a specific gateway, in this case, the C-Grid gateway, the Science Engineering Application Grid Gateway, and a data infrastructure called RAPID, which is the robust persistent identification of data. And I'll talk more about both of those a little bit going forward. But to see if we could take what are the core FAIR principles, at least the technical portions of the FAIR principles, not so much the social portions, and apply them to a gateway environment and what that really looks like. So to set some possible scenarios, as I said, these gateways are tools for researchers. The researcher may be concerned that the digital objects they use or produce are governed by FAIR principles. They may have heard the buzzwords, they may have put it in their proposal, they may have agreed with what the word's meaning was, though didn't think so much about how to actually enable fairness. They may want their research to be reproducible outside of the science gateway environment. As I said, the gateways themselves are tools that will come and go over time. And I don't think we should expect that the gateway will be a permanent place that the research will live. Obviously, the data lives outside of it, the publications live outside of that. And in fact, you want your research to be reproducible, even if the science gateway is unavailable or possibly retired at that point after some number of years or some amount of effort. They may want to share the steps or the workflow, not just the results. So yeah, they may want to have some record of the workflow, again, outside of the gateway, to share with collaborators or to put in a publication. And they may want to reuse that workflow with some amount of tweaks. Say a new version of software comes out. I just want to drop in a new version of software. I don't want to have to point all of my new data at it, or all of the intermediate steps, just drop in a new piece of software. So those are some scenarios. But first, a reminder of what the FAIR principles are. Again, everybody knows the words, but I don't know that so many people have read exactly what FAIR means. And FAIR means several things. And this slide, produced by Luis Benino, shows the difference between the green is what can be implemented on a technical side or through software, whereas the black or blue, whatever you may be seeing, text is more of what is a social contract, right? So looking at F1, you can technically assign a globally unique identifier, but there's some social contract in saying that the systems that record that identifier will be persistent. The same thing with F2, data can be described with rich metadata, and you can make a mechanism to do that. However, the rich portion of that is up to the social contract and the researcher or the community to implement. The other ones here, and again, we centered on the green things, the things that were technically implementable. And I don't want to go through all of this because this is a relatively short presentation, but we focused on those things in RAPID. RAPID, the robust persistent identification of data, is basically a handle service or a PID issuing service, and that holds the metadata, resolves to the global system, the same global system that is used for DOIs, and many of the other data site uses it also. So I'm going to move in. C-Grid here is basically a relatively general grid for science and engineering applications. It's built on Apache Ariavada. And the adoption that we did here was centered on small molecules and their fluorescent properties. I will show a bit of that if I have time here, because I want to show you how you take what you've done in a gateway and actually find out information about it externally. So the Rapid Testbed is a data cyber infrastructure. It's something I've been funded by the NSF to work on. It is entering year 3 right now, but basically it has the cyber infrastructure for minting PIDs, resolving them to get metadata, a data type registry, so you know the meaning of that data and what type it's actually in, and then a protocol. In this case, it's called the Digital Object Interface Protocol that allows operations on digital objects. And it's basically the cyber infrastructure that it's a cyber infrastructure. It's not the only cyber infrastructure that does it, but can implement those technical components of the FAIR principles that we looked at a few slides ago. And it leverages several things from RDA and then some existing software, including a persistent identifier kernel information strawman profile, basically a profile of the metadata and the data types, a data type registry. And then it does, the group within RDA called the Data Fabric Working Group theorized a bunch of this. We took it to the NSF, got funded to work on it. And there's more for this at the link here below. And here's the idea of using PIDs. PIDs are cheap, inexpensive, easy to issue. And so what if we assigned PIDs on every step of the workflow? So the raw data, either in the file or the raw data file are in other formats, can be assigned a PID for each piece of that. Any preparation software or pre-preparation can be given a PID. The same with intermediate data products, the final analysis application and software, and the final data products. They all get persistent identifiers that are resolvable with metadata about the workflow steps. So the simple example of the phosphorescent molecules, or the fluorescent molecules, sorry, that I mentioned earlier, is shown in this tree. It's really, this is a very simple, but basically the workflow itself is given a PID. So when you hit submit a job, it's given a PID for for a group of other pieces of metadata. It's split into input, software, and output PIDs. And these have various different things. The input has the actual molecule, in this case, the coordinates of each of the atoms in the molecule, the charges on those. It also has some of the things that are used in input for the, in this case, Gaussian software. The software PID has the name, the version, and other bits and pieces. In fact, the software should probably be split into a software and environmental PID because some of the things we captured in the software PID are more environmental type variables. And then the output ID has the error, the output, and the log information. So these could all be assigned to PID. These are all retrievable externally. So if 2 months later I want to go back and see what version I'm writing the paper 2 months after I did the initial run, I want to know what the exact version of the PID, or I'm sorry, the exact version of the software I used, I can do that. And I will show that here real quickly. I have this set up, whoops. So this is the Ariavada, and let me get it on a bigger view here. The workflow, you can see this is a workflow I ran a few months ago. Again, I'm writing a paper today. I have a, for example, if this gateway is gone, I still can get this PID. I have this PID, I take it to the handle.net, which is the global resolution system. It sends me back to the rapid services. Here you can see that I have PIDs that are the input data, the output data, and the software data. In this case, I'm looking for the version of the Gaussian software as I write the paper to make sure that it's not or that it's correct when I publish this. I can follow this PID down here to find the app module version. I can grab this from right here. Again, I don't need any access to the gateway to do this. And I found my version. I can put that in my paper. If I want to change that version in the workflow, I can put in a PID that is, a new version or a different version or something along those lines. And I think I'm running out of time, so I will get to my conclusions here as soon as I can exit full screen mode and get back to my presentation. Okay, so we did this integration. Sigrid is working with this. It's available at rapid.sigrid.org if anybody wants to play with it. And it implements the issuing of PIDs, the gathering of metadata that is resolvable externally, and it does use actually the digital object interface protocol that I talked about. And these describe basically the workflow components. You can use this to recreate the entire computational workflow without having any access to the gateway. So if a researcher picks up your paper and says, I want to recreate this workflow, but I don't want to do it in the gateway environment, they can do that by getting all of the metadata information about the workflow that was used within the gateway. Again, this well, not again, but this directly impacts the mostly the FA and I parts of FAIR. So the FA, the R has much more to do with the reusable with the social contracts and the metadata that is required to be gathered. So it's much more of a discipline or a community enforcing that to make those reusable. Nicely, this is extendable to other area VADA-based gateways pretty easily. In fact, we have a client, so it could be moved to any gateway, not necessarily just area VADA-based science gateways. And it leverages the RDA community, and in fact, was funded by the RDA. So we have some future work, document the client deployment. There is documentation, it needs to be tested and maybe reworked to be more user-friendly. We did this on a very simple workflow. We'll have to do more complex workflows. So something like the common workflow language may need to be integrated. I showed it in the tree structure. It's probably more of a DAG structure, a directed acyclic graph type structure of what workflows really work in. We wouldn't want people to have to copy and paste through various different things like I showed through various different web pages to get the information. So it needs some sort of workflow visualization that is representable in something a researcher could read quickly without having to copy and paste many PIDs to get the information. We're looking at the possibility of then using the data to populate public repositories. In this case, the floraforbes.org, because this was fluorescent materials. And the other ones, Rapid itself right now is in the Testbed service. It was funded in the Eager Award, so it would have to operationalize to be used in general. It's a very stable and very robust service running on Jetstream right now, but it would need some operational components. And then we have some testing that's been done on the performance of how many PIDs can be both resolved and issued, and they're in the hundreds per second. However, that comes from the developer of that service, so we would want to do some independent performance analysis before we release this widely into the community. And with that, I will see if I can escape and stop sharing and take questions. Hopefully, Suba, that was in a reasonable time.
I think so. I just went 1 minute over. That's fine. So thank you, Rob. And any questions for Rob? And I see one in chat. Let me quickly see. So the question is, have you implemented this on any non-Apache Airavata gateway to date?
So no, to date, we were only funded to do this on the one gateway. It was a small, short award, ran from January to June of this year. It funded about 20% of a person. So this is the only implementation we've done. However, the client is independent of Apache Area Vada and can be picked up from GitHub, reused. Again, the instructions probably need to be gone through, but we would love someone to test it and see if the instructions were reusable outside of the people who have developed it. But there's no reason that it can't be done. It just hasn't yet.
Any other questions for Rob? Maybe I can ask one. So what was the level of effort that was needed to change, to incorporate this into Cgrid, because Cgrid was an existing gateway, right? So what is it? Maybe you can give us an idea of the effort involved.
So I can give you so for those 6 months, it funded approximately 0.2 FTE. However, that was the initial interaction, and I don't think that it would take that long again, because now we have the client again independent. However, doing it the first time takes some amount of effort and some integration, and I would see that future it should not take nearly that much. If it takes that much, then obviously we don't have a product that can be reused widely.
I'm going to open the floor for questions for other speakers too. There is one question in the chat. Do you have any Cgrid or other users' experience with using this? Is there a use case documentation yet that can be presented?
So there is not a use case documentation as of yet, though that is a really good idea. What we did is the proposal of the idea to RDA, and then the implementation. The Sudhakar, who is the PI for the Cgrid project, was the one who brought the use case of the fluorescent molecules and some work that's being done here at IU. So I think we had kind of a use case to be directed at, but Sudhakar has his hat in a gateway community also. And what we need to do, I think, at some point in the near future, is go back to the actual researchers. One of the things they did bring up was that it would be good to publish information to the fluoroforbes.org or some public repository of fluorescent materials.
Any questions for all our three presenters today?
I do have a question for the MFT presentation. I wonder if you could talk a little bit more about the way the accounts are authenticated, how that works in your system.
You're muted.
So yeah, it's a good question. So if you can remember, so I mentioned that so you have the full functionality to plug in your own credential backends. So we from the MFT side, we act as a stateless entity. So what happens is that if we get a request any request can contain a token. So what happens is that that token is routed all the way through the credentials backend of your implementation. So then you can so the advantage you get is that you don't have to think about the MFT specific security implementation. It's like you get the token and you can validate from your end and give the access to get the credentials or the resource information. So yeah, that's the idea. So you have the full control over the authentication, not authentication. You have the full control over the authorization of the entities, because we assume that we get an authenticated request from the API.
Okay, thank you.
Yeah.
Are there other questions? If not, for James, I have a question. So in the drive, is there, I mean, I missed that part maybe, is there a way you capturing metadata along with the files and everything?
Yeah, luckily, I mean, I think DAT, which is now called the Hypercore Protocol, was a deliberate choice because of a lot of the really nice functionality that already exists there. So for instance, it has a full change history as well. So it's quite similar to what you see with Git and other kind of version control systems. And there's also a very vibrant community there. But I mean, specifically about metadata, yeah, seeing who changed the files, when they changed the files. I mean, what you would normally see with version control.
I see. Okay.
Yeah. But yeah, again, the community is great, and what the community has managed to do, like the Beaker browser project, for instance, I would recommend people to check out to build on the metadata that's on that protocol. There's some really cool work happening there.
I see. And is there, like, other gateways who are not part of the HubZero, can they take advantage of it, or is it just, for projects that are built with HubZero for now?
The protocol is open source, and it's funded by other mechanisms. Yeah, so I think anybody can. It's just a protocol, right? So anybody can look at that. Anybody can build upon it. I think what HubZero has done, and what we are doing, because this is very much a prototype, as I mentioned in the talk, is how we are able to leverage that protocol and then integrate it in the components that we have in the gateway already. So publications have been there forever, projects have been there forever. It's just the overhead, because those components have kind of been there with the traditional page loading, clicking web kind of interfaces, feels quite heavy from a user experience standpoint. And what we really wanted to do was let people, hey, I'm collaborating, I want to create a project. It should literally just be dragging this folder into this special location, and boom, the project's there. And then with one click, start a publication, and all the files that are part of that project are part of that publication. So it's something that we've been doing for a long time, projects, publications. We just want to streamline that user interface.
Okay, thank you.
I also saw a comment about my lighting. I apologize. Since I'm in Amsterdam, it's very dark, so I'm a bit redshifted. I don't know.
And James, I was wondering if you could talk a little bit about, I'm sorry if I missed it, about the performance and sort of the reliability of this protocol, this transfer of data.
Yeah, I mean, it is a peer-to-peer protocol. So it's kind of the redundancy between peers can be a problem. But the way that we can solve this or get around it is by letting our centralized CMS server also act as a peer or a pinning service. So not only can users say, I'm interested in getting this data, but the server itself says, I'm interested in that data. So it pins that data and then acts like an everlasting peer. So even if peers leave the network, they're no longer discoverable. As long as that centralized server is there, it's available as a peer.
And this centralized server is what you also have on the HubZero. Is this part of what you're offering? Is that correct?
Yeah, it will be. Yeah.
Okay, thank you.
There's one more question, James. Do you have a sense when this feature will be available for other HubZero gateways?
Yeah, I mean, it's again in the prototype phase, and I think one of our main drivers going out and speaking about it at the conferences here this fall is to try to get a sense if people are really finding it interesting. It feels like people are. So I would say it's on the roadmap, and it will be there. Probably not in weeks, probably not in months, but yeah, it'll be there soon.
Thank you. Any other questions for our speakers? I think we have 2 more minutes, but we can, take the 2 minutes back. If not, then let's thank our speakers. We have and thank you all so much for joining us, and thank you, Abe, for being the technical host. There is a break now, and after the break, learning labs will begin in the marked session rooms. Topics are posted at the welcome help desk and on the schedule, and with the list of rooms displayed along the left side of the Kiko chat. But thank you, everybody, for joining today.